Now that we have two-dimensional quadratic inequalities, the rules are going to change just a very little bit. But the good news is they're going to be a combination of rules you hopefully already understand from earlier work. For this section, I do think that all the examples will be simply like an x squared and then plus or minus some kind of constant. So we should be expecting that parabolic shape with the y-axis as its symmetry point, and it's going to just be moving up or down from here. But we're still going to make these tables, and then we have to make decisions like, am I going to use a dotted line or a solid line? And then where am I going to shade this thing? And the dotted line, solid line part, as you'll see, is the exact same as it was before. But let's kick this off by making a table. Because I'm promising you that these parabolas will just shift up or down, we're safe to go ahead and pick 0 as our middle point. That's where the vertex will be. And if I plug in 0, that means I want to also plug in a -1, a -2, because those are both less than 0, and then 1, and then 2. Now, plug all these into this original function. It's better to use your brain than your calculator here, because people often will use their calculator incorrectly. -2 squared is a 4. Plus 5 more makes that 9. -1 squared is 1. Plus 5 is 6. 0 squared is 0. Plus 5 is 5. And then for 1 and 2, we're going to have very similar calculations. Oops, that should be a 5. That should be a 9. And now we'll go over to our grid and plot the points. So you'll be using that point plotting tool that Alex provides, or you can, however you want to do it, enter the coordinates or just plot the points depending on how pretty they are. And then I'll have to make the decision, do I want to draw in the parabola with the solid or the dotted line? And just for the record, solid line means that we're going to include the points that are on that parabola. Dotted line means we'll include all the points up to the parabola, but not the ones that are actually on it. So it's the same rules as before. If you're seeing something like this or like this, and it's going to be less than or equal or greater than or equal, anytime it could be equal, you want to include those points. It's the same reason why we color in the circle. We're going to use that colored in line. Whereas if I have strictly less than or strictly more than, I would not want to include that point, so I'll have an open circle. That's what the dotted line is. In this case, I've got greater than or equal to, so because of the equal to, I'm going to go ahead and use a solid line to graph my parabola, not a dashed. And now, how do we decide which way to shade? So this parabola takes the plane and it breaks it into two regions. A region that I'm going to call blue and a region that I'm going to call yellow. I'm not going to get this whole thing shaded in, but you get the idea. All the stuff outside of here is yellow. All the stuff in the parabola is blue. You don't really want to be thinking, though, so much inside or outside. You want to be thinking about what the heck is happening with y. For this inequality, they want y to be more than or equal to whatever that parabola was. So let's focus on this y-axis for a second, and actually specifically where that parabola hits it. So it's the same question as when I was working with the linear inequalities. On which direction is y getting more than? Is y getting more than if I go this way? Or is y getting more than if I go this way? And I hope it's clear to everybody that as we move up, y gets bigger, which would indicate that the blue region is the correct region to shade. So my final answer as a rough sketch, would look something like this, solid parabola with those points specifically plotted, and then all this stuff is where I would want to shade. So good luck with that as you move forward. Hopefully you can see the connection to linear inequalities and graphing parabolas and all that kind of stuff that we did before. If you do have any questions, you do know how to contact me. So good luck with that, and I'll talk to you guys later.